Hello, everybody. My name is Sebastian Schneider. I am the responsible product manager for the 7VU85 HSBT device. Today, I would like to present you general introduction of the high-speed busbar transfer system. We will go a little bit deeper into the technology and the physics behind, and where we need a busbar transfer, and of course, what are the specific requirements for a busbar transfer. And in the end, of course, I would like to show you how to select the 7VU85 in our Cipotec 5 configurator. Now we step in. What is a high-speed busbar transfer? A high-speed busbar transfer is used in applications where we have motors, inductive motors, asynchronous motors on a busbar, as shown here in these applications. And why we needed this kind of device to transfer the motor load to an alternative incomer, for example. And how we do that? We transfer it from open the breaker, the CB1, and close the CB2. But for that, we needed to do it very fast with high speed, to have an uninterrupted power supply on the motor bus. And of course, we have a requirement, and this needs to be safe. That means the transfer needs to be safe over the time. So that means we have to protect the motors, which is connected to the bus bar. And of course, we need to reduce the impact on the power supply himself. Where we have such a kind of high-speed busbar transfer, where we find this? Of course, we find this in power plants. We find this device in petrochemical industry. We find it in pharmaceutical industry, hospitals, data center, and semiconductor manufacturing. All in this application, we need this kind of device to ensure an uninterrupted power supply. When we have a closer look here to one of the most important application, this is mainly used in the application of a power plant. You see here on the left side, you see here the single line of the power plant. So here we have the generator, here we have the step-up transformer, and the main in-feed. So here we have the auxiliary transformer. This is the motor bus or auxiliary bus. And then we have an alternative incomer with also a step-up transformer. And where we find this application? We find this application in coal-fired power stations, gas-fired power stations, combined cycle power station, for example, or in nuclear power stations. And of course, in nuclear power station, such a high-speed busbar transfer system is very important, because we need to be sure that the cooling of the reactor is provided at any time. So, and therefore, we have requirements for a busbar transfer system, and one of the requirements is that we have a manual transfer in case of a plant startup or shutdown of the generator. That means we have to make the transfer from the main grid to the auxiliary grid, or in the other direction, to start up or to shut down the generator. And then, of course, if we have a failure on the main in-feed, then we need to transfer as well the motor load from the main in-feed to the alternative source. The other application is an industry station or industry application. So here we have a typical industry application. We have the motor bus here with the motors. And then we have in the middle here a sectionalized CB or tie CB. And we have two incomers. So, and this is mainly used in industry where we have a continuous industrial processes, like in iron or steel plants. Or we have a flammable or explosive environmental, like in chemical or petrochemical industry. And therefore, we have as well some requirements for the HSBT system, and this is the automatic transfer, like in the power plant application. And we have a manual transfer, of course, when we want to go back to the normal operation after fault clearance. And in case of a maintenance, we also want to force the transfer, a manual transfer, to make the maintenance here, for example, on the transformer or on the main in-feed. And why is such a HSBT system or transfer system necessary in industrial stations? Of course, it is necessary because we have a large numbers of asynchronous motors which are working on the motor bus, and we need a continuous and we need to be provide, or we need to deliver the energy for the continuous industrial processes. In case of a fault, of course, we will lose the main infeed and the motors running down to the state still. And this can't meet the continuous process and will bring enormous economy losses. So on the other hand, I see a bigger risk or serious risk for the safety. In chemical stations or petrochemical stations, we have flammable or explosive environmental. And if the power supply is interrupted, this will cause to a serious risk to the safety. And how we can help the customer to ensure a continuous industrial process and, of course, the safety. Yeah, for that, we check at first the busbar voltage to understand why we need this solution before we provided it. If we have a closer look here to this fault record here, we see the motor is running down. And we also see here on the right side himself, there is a circle diagram. This circle diagram is coming from, or this is the circle diagram of the voltage. So, and you can see here, the voltage on the motor bus is changing after we lose the main infeed. So that means the voltage, the amplitude is decreasing, and also the frequency is decreasing in case that we lose the main infeed or the infeed of the motor bus. So, and therefore we have to consider here these kind of characteristic for a busbar transfer system. Yeah, what are the key requirements for in continuous industrial process? How can we met them? Can we met them with an automatic transfer system? Oh, we will see. An automatic transfer system, it's, I think, an easy way to transfer one load from one infeed to the other infeed. The principle is based on the voltage amplitude and on the frequency on the busbar. And we are closing the breaker on a very low instant. So that means mostly we are closing the breaker on the dead bus. So that means it takes several seconds and the voltage is going down to zero. And of course, one of the parts of the motors are tripped because we are losing the voltage. And for large motors, of course, we cannot provide a continuous process. So the process is interrupted. And in the end, of course, the influence for the power system will be after the voltage comes back on the motor bus, and then we start the motors in groups, and this brings a large current to the power system. So that means, yeah, a normal ATS system can't meet the requirements. Now we have a look on an HSBT system. So the requirements for this transfer device is that we have to transfer the load in high speed. And of course, when you remember to my second slide, we need to do it safe. That means we need to limit the impact current and the torque at the closing instant. Can a high-speed busbar transfer system help in that case? We will see. The principle of the high-speed busbar transfer is that the voltage amplitude and the frequency on the busbar are very high at the closing instant. That means we have voltage and we have frequency at this time. So that means we need to be faster. Of course we need to be faster. So we need to be faster than less cycles, less periods. That means in total, the HSBT system needs to be faster than 200 milliseconds to fulfill this requirement. And this is including the breaker time. The influence on the motor should be less. because we want to ensure a continuous industrial process, limited impact current and also limited impact torque on the motor at the closing instant. The influence on the power system should be also less, because when we close the breaker very fast, then we will not have so much high starting currents in the system. Comparable with the ATS, an HSBT device meets the requirement for a continuous industrial process. Let us talk about the results or the conclusion. So that means an HSBT device is high speed and make a safe transfer. So that means we deliver an uninterrupted power supply to the motors. We have a safe transfer with smaller impact current and smaller impact torque. We use the residual voltage character on the motor bus for the asynchronous motors, which are connected because of the decaying sinus wave. So that means the amplitude is decay, and also the voltage gets a linear decay. So, and the phase angle, of course, is changing over the time. Comparable with the ATS is an HSBT suitable for such an uninterrupted continuous operation. Now we come to the device selection. I think you know the Zipotec 5 configurator. Here in the Zipotec 5 configurator, you will find on the last position the HSBT device. You make a cross there, and then you come to this view here, where you have to select the predefined standard variances. So we have up to 4 standard variants with different I/O modules, with different binary in and outputs, with different numbers of voltage transformer and current transformer. But these standard variants match to our application templates. With the version 9.60, we already want to bring some new, or we want to bring some new application templates that we have in total 5. So, and you see here that application template match to the hardware variants what we have predefined. But of course, this is only a proposal and should help you to select the right hardware for some standard applications. You can change these at any time, of course, and you can add some additional modules, you can add some additional communication card and so on. If we have a look here on the typical applications, and then you will see, okay, there's not so much variance in the typical application. So we have here the single bus bar with 2 incomer. We have here single bus bar with an intersection CB and 2 incomer, or we have here a single bus bar with 3 different incomers. And you see also the hardware needs to be bigger for such a more complex application. If we go back to the configurator, then you see here that page where we show the corresponding product code. We show the numbers or the sum of IOs and CTs and VTs. You have here one part on the configurator which is describing the housing, the HMI, and as well the power supply. Here for my chosen hardware variants, I have choose here the push button front to initiate a transfer, a manual transfer, for example, or to stop the transfer, or to block the transfer. So this is very suitable, and we saw that in some different applications, it makes absolutely sense to use here these push buttons. On the other hand, here we have the plug-in modules for communication, and last but not least, here we have the possibility for the function point calculation, and therefore we go a little bit more in detail. Because this right selection of the function point calculation is very important for the application. In the end, we have up to 5 application templates. The basic application templates for single bus bar with 2 incoming breakers needs 0 function points, but if we come to complex applications, then we need to count, for example, the circuit breaker, how many circuit breaker we have in our application. This needs to be defined here in the function point calculator. And as well here, the HSBT function. We need to define, we can instantiate it 4 times the HSBT functions into one device. We need to define diff transfer groups, and we need to define diff transfer directions for each HSBT application. So, and in the end, please do not forget to confirm your choice. Otherwise, you order a device with less function points. But don't worry, you can order function points via the function point manager afterwards.